Hello.
Hey, one sec. Okay. Hey, how do I dismiss this window? All right. Okay. Oh, close. There you go. Okay. That's great. Excellent. Yeah. Hey, cool. Good to see you. Hey, Nathan, are you there too?
Yeah, I'm here. My camera is
Awesome.
taking a bit.
Yeah. No worries. No worries. Okay. As long as you can hear us. And it's, if you miss out on, if we do share the screen and do stuff, and you can always watch the recording. I think it is getting recorded. Yeah, okay. Well, anyway, so the problem here is you're going to do this all yourself, obviously. So here's what I'm thinking. So here's the problem. Suppose I give you a random piece of text and I say, of all the authors, famous authors, like Jane Austen, Shakespeare, whoever, right? Byron, Mark Twain, whatever. So who wrote this? Now it's possible because most people would know all these famous phrases, right? And they place these things and say this. So this was written by Mark Twain and all. So how do they do that, right? How would you do that? So take a typical problem, very classic problem actually. So it's text classification. I think this is what I said we'll do. Yeah, it's text classification, and I can describe the statistical insight behind it. It's very easy, very super duper easy. Okay, and you know about hash tables, so you can actually do this in C++. In fact, Matthew also did it. He was a 2C student, and he did it using hash tables. And it was very nice. Lots of people at the STEM Center loved his demo. There's lots of people crowded at his station. So anyway, here's the thing. You can before doing it the way that I'm going to suggest, I would like you to basically just think about what you would do, right? So if this is the problem. Now, just scale it all down. You can say that, instead of saying just arbitrary, any author out there, which is an open problem. You can do that, right? That is how Google and all these other people build language models and all, right? Because in real-time data. But let's keep the problem really small and say, let's say 15 famous authors from a famous repo, right? Later on, you can write a crawler, a scraper or something that will build up these big data repos for individual authors and and metadata and things like that. For now, just to keep everything really simple, is just 10 authors, and then I think there is a site. It's called Gutenberg.org.
Yeah,
okay?
Project Gutenberg has all the books.
Yeah, so you can basically download every single thing that you have on these people. Okay, now the challenge here is that in fact, you know what, here's a good way to do it, right? Maybe you'll just do it yourself, without me telling you this is the way to do it. Okay, so I'm not even going to tell you what I'm going to propose, how Matthew did it, for example, right? I'm just going to say this is the problem. Do it. If you don't have any way of tackling it the next time we meet, I can give you a way to do it. If not, we'll take what you've done and see if we can, tweak it around to see, if there are any obvious places where your, model might fail. Yeah, and we can address those. The only constraint is that if you're going to use machine learning and all, don't use opaque models like deep nets and things like that, where you don't know what the parameters are. Yeah. Because because people say I can drive a deep net, and so that makes me a machine learning engineer. But so it's a very cloudy term out there. So people who drive it don't know how it's done. A lot of the ingenuity of machine learning actually goes into preparing the data in a way in which the deep net can actually use it. From many of the quests, the basic algorithm itself is sometimes very simple. But getting all the nooks and crannies right is really the hard part. And that is how it is in machine learning too. Cleaning up the data. Lots of ingenious ways have gone into how the data can be shifted so that a particular dimension of it, in fact, I'm not even talking about, a particular perspective of it, right? So let's not go mathematical, right? A particular perspective of it is emphasized. Right, so maybe you apply some kind of a function that says, well, this function is going to actually, amplify all these data points, whatever it is, right? As you come up with this incredible function, and it actually does it, and you look at it, the data transformed this using this function, which is really, it's the same data It's not a transformation. It doesn't become new data. It's just the same data viewed through a different lens, and you can see a completely different picture. Yeah. So, but the thing that sees the picture is, it's opaque. You can't see. It's trillions of parameters in a deep net. Nobody tries to make sense of these things these days, right? So most of the time, what we tend to do is just treat the deep net like a child. I'm talking like, I know about these things, but this I think is the natural way in which a computer scientist would design these things, right? So treat it like a child in the sense that it is something that can react in predictable ways, given the right input. So the ingenuity of raising a good deep net is really in the good parenting of it. And just saying, this is the data that it will actually make you, give you the ability to make these fine-grained distinctions. Because otherwise the loose cuts will be very coarse, and samples will fall on both sides. You don't know whether something is a positive example or a negative example, so it's lots of gray areas, yeah? So you want really lots and lots of really, really good data points so that you'll refine the razor and say, well, you know what, I actually got a proper hyperplane, right? Not a hyper sponge, right? Hyperplane, so that any point you give me, I can tell you which side of the plane it lies in. Yeah. So that is really the heart of machine learning, no matter what you do. So I think that is why in community colleges, I think it's also a danger, because lots of students get sucked into, right? Oh, machine learning, it's the word of the day and all. I think I had a one-on-one with one of my two-way students who was planning to go into machine learning. Maybe he was curious about it, but he eventually decided he's actually UCSC at gaming. He's doing something with games. I think he's doing my 2B right now. But that's what it is. Okay, machine learning is just like any other science. You just have to come up with ingenious ways of presenting different cuts of the data. That is what the bulk of it goes into. The theoretical part of it is just another science. It's like a math, right? And it doesn't matter whether it's machine learning or, in fact, what I believe is that once you get down to the nuts and bolts of the science of the thing, it doesn't really matter which field it is, whether it's physics or chemistry or biology or whatever it is exactly the same. Yeah, because it is just fine-tuned reason. And and making decisions based on what is available for us to see, and not making decisions, just suspending our judgment on what we don't have evidence for, which is really the more hard part, right? Making our judgment based on what you can see is easy, but most people find hard the other thing, which is suspending your judgment when you don't have evidence for it, right? You just look at the average Joe out there, right? They have thousands of beliefs, they have no evidence for it. It just it makes me feel special, so I'll believe it. And so that is where the scientist in you basically shines and say, well, you know what, I have the power to do both things. I can both form, when I look at the evidence, I can draw a fine razor. That's basically what you're saying. That's basically what machine learning is. That is why I think that machine learning at its core is basically pure science. All of these other sciences are empirical sciences. Even these, but machine learning is the abstraction of empirical sciences. So it's still an empirical science because it's driven by data and modern measurements from physical devices. Yes, because otherwise, it's just math. So it leaves the paradise of math and comes down to empirical earth, right? When it says, well, you know what? Okay, I'm going to let the finite measurements taint this incredible citadel I've got. Essentially, isn't it? So machine learning, in a way, is really contaminated math, but it's contaminated in a way that humans can live with, and it's beautiful and all. So that's why it's just science. However, it is not a particular science, but I think that it is actually an abstraction of all sciences, because no matter what field you take, what you're really going for is what is true and what is not. Can I have a razor that tells me this is predictable, that is going to happen, that's not going to happen? Yes. Whereas biology or whatever it is, we just want to find determinants. And when we cannot find a determinant, we're like totally lost, like Heisenberg theory. There's no determinant for something that happens. It completely throws everything in the, yeah. So that is why it is so jarring of an effect. And I think, so that is, if you approach machine learning with this, I think you'll have a great success with it. But I just want you to know that there's lots of exciting things to do also other than machine learning. Certainly this will be a good project, okay? So the challenge now is, in fact, why don't we say we'll just, next time we meet, maybe it can be tomorrow too. What tomorrow is Tuesday? I got a class. Well, we'll play by ear, probably tomorrow if you want. Take until tomorrow. Because you guys are not doing anything. You finished quest 9, so you got a lot of time. Okay, you got to still go through the LOCIF stuff, okay? Because lots of algorithms we didn't cover, like the thing that Nathan brought up. This is some sorting technique, yeah. So that wasn't in the quest at all, and it's in LOCIF material, yeah. So there's and you can also go through the text, because lots of interesting algorithms in text that LOCIF also didn't cover. You got to pick and choose along the way. So you can look at the text too, but certainly everything in LOCIF will be in the exam. Well, not everything, but there'll be a good selection of those. Yeah. Anyway, so I think this is what you can do. So take until tomorrow, and together the two of you just pick 10 authors. Okay, 10 authors from with a reasonable. Can pick. So I think there are some authors who don't have a lot of works to download. Okay, so just pick a bunch of authors, and then let's say you're able to download at least 100 megabytes each author. Okay, so you have a total of 1 gigabyte of data. How about that? Okay, so you should be able to download about 100 megabytes. I think that's it's okay. I think that's possible. 100 megabytes, 100 million characters. Who would have written 100 million characters? I don't know. Okay, you got to find out. Okay, so download as much as you can from about 10 authors, and then the challenge for you is divide up the data. Well, okay, the challenge is going to be, hypothetically, you will be shown some part of the data. Maybe you're shown 90% of the data, right? Maybe, who knows, right? 90, right? And you're not shown 10% of the data. And the remaining 10% of the data, only the Oracle knows. And so the Oracle will basically throw a sentence at you and say, who wrote this? Well, maybe a paragraph at you and say, who wrote this? And you've never seen that before, right? So you've got to make a decision. And to make matters easier, you don't have to say, you don't have to make a hard decision. Yeah, you don't have to make a hard decision. You can say the probability that it is Shakespeare is 60%. The probability, essentially what you're saying is the probability that the author is Shakespeare, given that the text fragment is this. Yeah, is so and so. So according to this measure, we think Shakespeare is the most likely guy who might have written that. That's all you have to say. Right now, you don't have to approach it in any particular way that I'm saying. And in fact, you might find that you have to do a lot of text cleanup and text normalization, and using Python scripts or shell scripts or whatever it is. If you need help, let me know. Or you can just use an editor, right? Uppercase, lowercase, and do all these things yourself. But you got to clean up, okay? You got to write some scripts to clean up. And then you have all the time at your disposal to come up with a way in which you write a C++ program, okay? And then together we'll write a main method, okay? And in the main method, we'll just copy and paste a random piece of text from somewhere, okay? And I'll say—
I could actually ask a question about the specification, right? So at the end of the day, right, what we want to be able to do as a final product is, given any piece of text of arbitrary length, right?
Yeah.
To classify based on an input set of authors, which of those authors that text is most similar to in style.
Yeah. Okay. All right. Okay. I think that is a very nice way. Maybe you should, maybe you should capture that into words and share it somewhere. Yeah, I think that is a good way of saying that. It's a finite set of authors, like you said. You'll be given those finite set of authors. You just have to find out, classify. But you don't have to employ a probabilistic technique. You can employ any technique you want. Okay, it doesn't matter. Maybe what you choose will be better than what I have in mind. Yeah, so it doesn't matter. The only thing is you don't use any opaque models. It has to be. But mainly saying that if you make a decision, you say you have a reason to make that decision. That's all.
All right, and
so
you're talking about in this project, right, using all kinds of these deep nests, which we shouldn't be using, right?
Yeah. Don't use any of this.
Right. So that's kind of an overcomplication of the problem. We could solve this in a much simpler way.
Yes, totally. Just go for the simplest solution you have, and then what we'll do is just try and refine it.
Okay.
We'll try and refine it and see how we can make it faster, smaller, better, more flexible, more able to handle more kinds of input. All these things, right? So get the simplest thing you have working, and then we'll take it from there. How about that? Is that a good idea?
Yeah.
Okay.
And then
so I think
we should probably be able. Good.
You have 4 weeks. You have 4 weeks left. I don't, you shouldn't be doing this in the last week. You should, last week should really be devoted to the finals and catching up on the material. So for 4 weeks, I think you'll have a reasonable project that I can actually look at and say, well, that is a, worth enough points to top up your midterm score or final score or both of them combined or whatever it is, right? So that is really what it is. You just want to give me an excuse to say that. Does that make sense? If you have any questions, obviously you should ask me. Okay, okay. If you do want to use a mathematical or statistical method, that's fine too, right? And you can ask me about any questions you have about the statistics of it. I'm happy to answer them now. But you can try any method you want. Okay, not just one. Maybe you'll even try 4 or 5 different methods. Let's see what works. Yeah, like you said, I think the simplest is probably the best in this case. That is why I think that is probably why I think naive Bayes is so successful in a lot of these things where you just need simple classification. Like, is this email spam or not spam? We've tried so many models, maximum entropy and all these different kinds of models to classify spam. And who was it? Jerome Bellegarda at Apple, I think. At that time there was I don't know where he's gone now. Yeah, he published a paper in one of our conferences, and we had all these people. We had so many different models, sophisticated models of trying to classify spam, decision trees and all these things. And he just came and said, this is just a probabilistic likelihood classifier, and it was basically kicking ass. Time and classification speed and accuracy and recall was basically kicking ass compared to all of the other sophisticated models that you can't understand. Yeah, so it's not like the models start getting more and more sophisticated, and at some point you say, well, it's not. There's no point in understanding the parameters anymore. You're just interested in the behavior.
So as an entry point, right, to our looking at what we can do, you're saying that naive Bayes is a good thing to look at for what we're going to build?
I think so, because it's a good bridge to, you're already doing stats and math in college. Yeah.
Yeah.
So you'll be bringing a lot of that knowledge to bear. You know C++, so you'll bring your knowledge of knowing how to build hash tables, for example. Because you're going to be storing a lot of stuff and accessing stuff based on a hash value. I think, I don't know. Right, it counts and so on and so forth. I will come to the details of it later. So there's a lot of C++ knowledge, there's math and stats knowledge, and some professional skills you'll acquire along the way, which is, it's not just the theory, right? There's in order to get it to work, you need to do a lot of groundwork. Yes, like cleaning up the data. A lot of people underestimate cleaning up the data. It takes a long time. So in fact, even what you have tomorrow will not have perfectly clean data. We'll have to go. As we go through it, the model will improve, as well as the data quality will also slowly improve, because as you see, the model's not performing because it's got a capital DR for DR instead of a lowercase dr, right? So let's go back to our text filters and fix this so that the new data stream will now fix that. Yeah. So it's basically iterative, looking at the output and saying, hey, so we let something through, going back to the quests. And then I'm going to one more mini quest here, right? Tighten up the things. So just like that. Yeah, does it look doable? You guys have time for this?
Yeah, that sounds doable.
Okay. All right. Okay. So how about tomorrow? I will find a time. Probably you said 6 or 4. You said you're available till 4:30 or something, right? Tomorrow
Until 6:30.
On 6:30.
Yeah.
Yeah. I will try and find a time. Later the better, actually. Tell Yamm to. He's gone. So find a time as late as possible. Try and get something done. It doesn't even have to be, a very sophisticated model. Maybe a lame ass model, that's fine. So we'll take that, we'll pick that up. And he's entered the meeting again. Hey, sorry, I didn't realize you were sent back to that waiting room. I really shouldn't even have that. Yeah, Zoom says for some reason. Yeah, I can disable both. All right, yeah, pick a time whenever you think you'll be ready, hopefully tomorrow or day after. And then let me know what you have. Does not have to be a sophisticated model yet, but if it is, that's great. Okay, Doesn't have to be. And all the data, in fact, for your initial model is you're just getting all the bits and pieces in place. You don't have to have clean data at all. You can say, well, these are the downloaded HTML files. I'm just going to send the HTML files, with what are the tags and everything, all kinds of junk in there, even JavaScript and everything is going in. You don't care, really. So, but you want to make sure the pipes are all clean. All the data is going in the right direction. That's all. So once you've established that, saying, well, the data is going to come in here. This is the model. It's going to build some stuff, and I don't know, maybe it's just counting or making a wild ass guess, right? It's taking the data and flipping a coin. That could be a model too, right? So it's maybe that should be a stub model. A stub model basically says it's random prediction, and then you can replace the models, gradually. But saying, all right, not a stub model anymore. This is going to make a probabilistic selection. That's going to make an entropy-based selection. So you can just switch models like that. So. Give me a sec, okay? Hello? Hello? Yeah, what? Oh, yeah. Well, yeah. You haven't located the place, you mean? I think you're close, okay? I'm actually in the middle of a meeting. Yeah, I'm in the middle of a meeting. I'm very sorry, okay? But you're very close. Thanks, bye. Sorry. This is a package supposed to be delivered, and the guy couldn't find the place. All right. So yeah, and make any model, and then in fact start with just a stub model, okay? And if you have one more other than a stub model, that's fine. You say, let's say, in fact, you say you have a model that says, I don't know, it doesn't matter. Okay, so have that in place, and then once you have all of that, then you can say, all right, now one of you, you can share between the two of you and saying, well, I'm going to clean up. I'm going to write some SED scripts or Perl scripts or Python scripts, whatever it is, to clean up the data and transform the data from one form to another. And you can share that task between the two of you, and I can show you how to stick it all in a pipeline so that you get the final data that you can pull into the system. Yeah. You can just, for now, you just use cin to suck in the data. Just use cin to suck in the data. So just coming in via standard input. And
okay,
and,
so
yeah.
So right now, like by Wednesday or whenever we meet next, right? Like a good thing to do would be like first model predictor, right? So as we said, the output should be between 0 and 100% of how.
Can you yeah. All right. So I think this is much better so that it's clear and there's no confusion at all. I'll give you the command line that I'll give you a couple of command lines. Yeah, command lines. Can you share the screen, and then you can just take a screenshot and then we'll do that. All right. So we'll just go to the Linux terminal. You're comfortable with the command line too, Nathan?
No, not really. I just installed Windows subsystem for Linux yesterday.
Yeah. All right. Don't worry. Okay.
I'm
So
paying you
it'll
to
probably take a couple of days max. A couple of days max of working with Yamm on this thing, and you'll be, quite comfortable. All right. So as soon as you share the screen, I'll say, all right. So share a terminal. Any make a big terminal. Okay. Just maximize. I don't want to see. Yeah. All right. Great. Okay. Now, can you increase the font? Control plus or Command plus or something like that?
Yeah.
Okay. So what we want is, let's say you want to, let's say, okay. All right. Okay. So suppose I invoke the program. Can I just say that we'll be using something like argc and argv and all? You guys know how what argc and argv and all? Yes. Good. Okay. So here's what. So I'm going to invoke this program. Let's say classify, right? Classify. Let's call it classify. /classify. /classify. Right? Space.
Mm-hmm.
Space.
Yeah. Space.
Dash train. Okay. Space. Author.txt. Author1.txt space author2.txt and so on and so forth.
Yeah.
Yeah. All right. So and then hit Control C so that it doesn't. Yeah. And then hit Control C so that it doesn't try to run it or anything. So it's there. Okay, it's there. Okay. So I just wanted to be on the screen so that we know this is the way that I might, for example, as a customer, take your program.
Okay, so this would be like a possible input that would
Yes,
you would want,
yes.
right? And
yes.
okay, so I know how to do this with a bash script relatively, right?
Yeah. Oh, let me
Is
fill in the
there a way
comment
to
on
do
this.
it directly with C++?
C++.
Or you can do this directly in C++?
Yeah. Hang on. Let me complete that. Right. So what that does is there a way to put comments in there? Hey, you know what? Just start an editor. You know, what am I thinking about? Let's start an editor. We'll just write a page.
Yeah,
write a page
I'll
with all the
do a
comments that we
markdown.
want.
I'll add markdown.
Yeah. We're messing with the command line and all here.
Okay. All right. So.
Okay, all right. So just paste that. All right. So on the next line, you want to say this would produce. No, this would write internal model files. Okay, somehow, right? Yeah, it'll create internal data, right? It'll create internal data that models each of the n authors. Okay, in a fixed location unknown to other people. So which means you can put it anywhere you want. You just know where it is for now. Right. And then you can add further qualification there. For example, the model could be a bunch of the model could be n files. The model could be n files containing information distilled from each of the text files.
The model would be n files.
Yeah. So for example, so you say at the end of the for example, our internal model within quotes, our internal model. And then just put the internal model within quotes and not the our. Yeah. So our internal model. No, the quotes are only on the internal model. Sure. That internal model that I mentioned before, right? Yeah. Now you can get rid of the leading quote. Right. So our internal model, for example, our internal model could be a bunch of could be n files, could be n hidden files, or n files in a hidden n file somewhere. Okay, n file could be n files with data distilled from the n text files. With data distilled from the n text files. Would
it be from the n text files? Because we could pass in more than one text from one author, right? Or would limiting thing be you can only have one text?
I see. That's what you're saying. So you're saying Dickens 1, Dickens 2, Dickens 3. Yeah, okay. I think it makes our command line interface more clumsy, because then we have to have flags for saying, okay, author begins here, author ends there, and files. So we'll just assume that our pre-processing scripts will just combine all of Mark Twain into one marktwain.txt.
Okay.
Yeah. You can put that in comments too at the top. So we'll assume right at the very top, you can say, we're going to assume that all of an author's collected works will be in one file called author.txt. You can put it anywhere you want. Put a comment there saying we are going to assume still from inputs and input files. Yeah. .txt. Yeah. And at the top, you can say, what was it? All of the, all of each author's works. All of each author's works will be all of each author's. All of each author's works. You have the word the, all of the. So all of each author's work.
Yeah.
Right at the beginning. No, I see assumption space all of the author's work. Right? No, it's all of each author's work.
Yeah, that's what I wrote, right?
Oh, hey, Nathan, is it my lag?
All of each author's works.
Oh, now it says each. Yeah. Now it says no. I actually saw you your cursor move and edit it right now, like a couple of seconds ago.
Oh, okay. I guess it lagged. Sorry.
Yeah. Okay. Now, yeah, there's yellow thing. All right. All of each author's works will be in one input file. Example Twain.txt, right? Or Mark
Sure.
Twain.txt. Example Mark Twain.txt. Author apostrophe s. Yeah. Author apostrophe s.
It would be authors,
There's a lag.
bro, because we have multiple authors, right? But that doesn't really matter.
But it's each.
Okay, correct.
So it's singular at that point, I think. I don't know. Yeah, I'm not an
I'm not an
expert on it.
English major.
Yeah. I think it is apostrophe s, but doesn't matter. Okay, as long as we understand what's going on. Yeah, Mark Twain. That means.
Okay.
Okay. All right. So you're going to get like 10 text files. So and the presence of dash train means okay, you don't have a classification job right now. All you need to do is look at the model directory, wherever the model directory is. You're going to find a bunch of models in there. Read in all the models, and then classify this. All right. So go to the very end and say the other command that I would expect us to run is right at the end. Right at the end.
So this is the train one, right?
That's for training. Yeah, lots of horizontal
Okay,
lines.
and this would be for actually running it, right? For actually classifying.
That's for running it. Yeah. What is by Wednesday? Yeah, all right. Okay, doesn't just notes for you. Okay, so what you can say is for running the model. Yeah, for running the model. And you can say lots of horizontal lines. That's training, and then there's running.
Yeah, you can do this.
Yeah, so it'll be dot classify.
Mm-hmm.
And then no, you actually just say dot classify less than dot classify, and then the input to that comes from input.txt. Oh yeah, dot classify input.txt. You just say dot classify input.txt. That's it. Yeah, I think dot slash classify input.txt.
Yep, updated.
And then it's lagging. Then it still shows dash run for me.
Okay, I could reshare. Maybe they'll update it.
Yeah, I don't know. Yeah. So yeah, it's gone. Yeah, wow. Okay, that was fast. All right. Okay. So and what that does is basically just print out the likelihoods. It'll print out the most likely author, followed by the likelihood that it could have been anything else. Print out the most likely author.
Like greatest to least.
Greatest to least, yeah. I think that is good enough, right? And it doesn't have to be a likelihood. You can basically say score, right? Print out the score. Just say score. It doesn't have to be likelihood, because likelihood says automatically that you got to use a statistical method. This just be a score, and a score could just be tossing a coin, right? So change the likelihood to score.
No, I did.
Yeah. I think that's enough, right? And then depending on how you implement that, we should be able to modularize that, saying, okay, well, you know what? Initially, we use the random model to classify. Now we're going to say internally, you can have one more flag later on, right? Dot classify input.txt can have multiple models, right? So you can say dot slash classify dash model equals something. Okay, model equals random, model equals statistical, model equals XYZ, right? So
in the training
this is
phase?
testing. No, in testing.
In the
so when you test it, you're going to say, I want to use this particular model so right now, and suppose you say, you only have the random model, you haven't trained anything. And then when you test it, you say, by default, it'll test whatever. If there's only one, this is all UI. Okay, you can make decisions on your own. I just think how it's going to happen. So if you
we may have multiple models associated in one file, so we want to be able to run the different models and see the output, right?
I'm saying don't even worry about that for now. Okay, because that is all downstream. Once we've got lots of things working, then we can see how we can tie them together. So we just want to make sure that things are open for that later on. We just want to make sure that things can be modularized. That's all.
Okay, so for instance, using another model. So you're saying like random
Yeah.
or like model equals random, right?
And you can, obviously you can say, used model equals random or something like that, using model equals. Oh, you don't have to do all of it, right? You just say, used model equals random. And later on, you can say, and don't try and make it general at this point, okay? Don't try and add flags, although it's very tempting to say, I'm going to handle multiple models, okay, dash random, dash, dash statistical, dash tree, and so on. It's tempting to do that. Don't. Just say, it doesn't matter. It's only like a couple of hundred lines of code, because your data structures code is separate anyway. The UI code is what we're concerned about, talking about, right? The data structures code is not going to change.
Yeah.
And so it doesn't matter. You can just throw everything away and recreate everything as required at the time you need it. So right now, just say ad hoc code for everything other than data structures. The data structure code is what needs to be clean, and everything else, the UI code can just be ad hoc for now, I think.
Okay. Yeah, I don't think this part will take too long. So whatever, just looks nice.
Yeah.
Okay, so
okay.
Like,
and you can write a Python wrapper around that if you want. Okay. Yamm. So if you think that it helps to just write a .classify.py, and that will basically take all these flags and make all the decisions and invoke the right models internally, that's fine too. Right. At the end of the day, all we need is that the data is basically read, crunched, and the results are out. That's all.
Okay. So by Wednesday, we could have, let's see. So what would be some nice things to be done, right? So like by Wednesday, right, we should have the ./classify script taking
right. So here,
inputs.
okay, Yamm. What you're saying now is there are no promises, no obligations.
Of course. Yeah.
Yeah.
Just
so you don't
a good idea.
Right? Brainstorming for you to just set some
100%.
direction. Yeah. Okay. Great. Okay. So here's what I might say. So by Wednesday, hope to have a model that will make its decisions based on the relative counts of characters. Yeah, counts of words. Yeah, I think words should be easy. Yeah. So just make relative counts of all of the words. So that's the information that you have at your disposal for both training and testing. And for training and testing, and you're going to say by Wednesday, you're going to say, I'm going to calculate. Wow, Peter is so crazy. He's just jumping all around trying to get in here. Okay. All right. Okay. So that's all you have to do okay. No. Out. Okay. Hey, I'm sorry about that. He's just clawing at my door. So relative frequencies. You just say relative frequency. Everybody know what a relative frequency is, right?
So
it's very close approximation to a probability
of certain words, right? So like for instance, maybe an author uses the more than another author, right?
Yeah. Okay. And in the process of doing that, my hope is you'll run into some corner cases that need to be addressed, not programmatically, but statistically, right? So that's very interesting, isn't it? So in C++, in CS2C, we learned how to get all the corner cases programmatically correct. Now we say, all right, it's not just enough to be programmatically correct, because even if the program works correctly, there are some statistical situations where that might not work. Yeah. So we want to make sure that the statistical situations are also covered. So that is stitching up all of the corners so that your final product is now ready to go. And so in the process of doing this, you'll discover that, I'm using the counts is basically the best thing to do. I should just use counts and get it. However, using counts, there's this problem. So let me go to relative frequencies. Okay, that'll get around the counts issue. So that's one corner case covered. But using relative frequencies, you'll encounter other problems, okay, and more problems. And all of these things are basically just little nooks and crannies, just need to be identified and plugged in, right? Okay, that needs to be, we need to disambiguate between saint and street, okay, ST, or things like, I don't know, who cares, right? So things like that also, little things like that will creep up, and we just identify them. And as time goes on with a good data engineer, what happens to a good data engineer is that all of that just becomes internalized. When they look at data, they already know, right? I got like a 7.3 hours of work to clean this up, okay? All right, so they actually know exactly what needs to happen. And it's just, at that point, even for themselves, it's just a resource. Saying, all right, once I do that, it's ready to go into this machine. So, and that is that level of intuition is what makes for good, I think, data and machine learning engineers. Anyway, I think this is enough of a goal for Wednesday. Yeah, if you finish it earlier, just let me know and we'll take it to the next step. But otherwise, I think this is enough of a goal. You're given the data, and you can generate counts and look at these counts, and you store the counts however you want. Okay, .zip files or tar files, whatever it is. And when I call it with .classify, you can just print a message saying, hang on just a sec, I'm reading all the models, and that could go off like once in 1 minute, dot reading model. Okay. Yeah. And it's going to load all the files into a hash file, map of its memory. It's fine. Okay. And say, all right, models are read, and but gun is primed and is ready to go. Right. So now you can say input your text. Okay. And you say input, and you say file name 1. I'll say, oh, file name 1 was written by BAM. Right? Do you have more, or Control C? That's all. Okay. There's something like what our 2A students will do, just like a simple loop. The intending, like the test you're doing for quests. So you write your own tests in main to say, all right, call the method to see if it works or not. And that's what we're going to do.
Okay.
Does that make sense?
Yeah.
Yeah. That makes sense.
Is that like an interesting thing to do for you guys until hey, how are you getting these? How are you getting a histogram?
This?
Yeah.
No. This is get pull.
Oh, is it? Oh, wow. Yeah. Okay. It looks like a histogram to me. Right, cool. Nice. All right. So as long as it's interesting, that's fine. Okay. And then depending, and you never know, right? At the end of this, you never know what it takes you into. And you may see that, oh, right, I can actually use this to build a statistical model of things, right? And so on. And if nothing, when you go on to do grad level machine learning stuff, this will just come back to you automatically saying, hey, that's why he's talking about this. Okay, that, and most professors during the first couple of weeks in machine learning will spend in just introducing the cleanup and things like that. Okay, and you already know all that. You've done this, and you'll be much more well positioned to imbibe what's going to come. I think. I don't know, right? So it's just a wild-ass guess, but I think it'll be useful and interesting. And hopefully you may find something that you could just turn into a game or something. Like I said, who knows? Yeah, do you have any questions?
No, this is
all right. Okay,
sounds good.
So if you guys need to, let me know. Okay, let me know. Tomorrow I'm in class from 8 to 10. Oh, hang on. Right, I'm in class from 8 to 10, but Wednesday is fine. So I think Wednesday is open at this point in time. So I'm happy to meet on Wednesday.
Okay.
Yeah, Wednesday is okay.
Good.
Right? Otherwise, just let me know. All right.
Right. Thank you very much.
No worries. I'll wait for it to download. I don't know whether it's recording in the cloud or not. So I'll wait for it to download, and maybe tomorrow it will be online. Okay. So if you have any notes, but you have the screen, so you have all the notes right there. All right. Bye.
Right. Thank you very much.
Bye.
Bye.
All right.